Hey, this is Dino, and I want to show you the use of the WS security signing and validation callout. I've got these built into API proxies. First one I'll show you is the signing. So I've got an API proxy with a single conditional flow, sign one. It's fairly simple. It checks that it's got to be a post to that path suffix. It checks the content type is XML. Then it assigns a key and certificate, which is used in the signing process. Then we invoke the Java callout, and then with the result of the Java callout, the signed payload, just put that in the response and send that back. So what does the key insert look like? This is just the PEM encoded RSA key, private key, and also an X509 certificate that corresponds to that key that embeds the public key. Both of those need to be used in creating signing. What are we signing? This is the configuration for the Java callout. What are we signing? We're signing the message content. We're putting it in a different context variable. We're specifying the elements to sign in this signing effort. That is the timestamp, the body, and the to element, the WS addressing to element. These prefixes must be known in the inbound XML document. This is the crypto information, so that's the private key and the certificate. We're saying to this policy, we want to make sure that it's SOAP 1.2. This is how we're going to inject. This is the type of key identifier we're going to inject in the signed document. This is the digest method, the signing method, and the expiry. So really simple. And of course, the class name is the sign class name. So very simple. And when I invoke that, you should see and when I invoke that, you should see the output. Let me first show you the inbound document, the unsigned document. So that looks like that. Very simple. It's SOAP 1.2 namespace. It has a pre-existing SOAP header with WS addressing values, message ID, reply to, and the to. And then it's got a simple body, which is just sort of contrived. What we want to do is sign that, and that's what we did. So the result of that is here, and we have all the pre-existing message, including the SOAP header and the body, but with a unformatted WS security header injected into the SOAP header. So I could walk through all that, but it's kind of hard to read when it's all jammed together. It's important to keep this as it is and not reform the white space, change the white space, change the indenting or anything when you try to validate the signature. That is all significant with XML digital signature, which is what WS security uses for signatures. So you can't modify that. You can modify if you just want to see what's in there, but you can't try to validate the modified version. So let's do that. Let's drop it into an editor, and then we'll reform it so we can get a better look at what it is. This is the signed payload. So we can see that there's a new WS security header appended to the SOAP header, a timestamp injected in there, and you'll see that this gives the 60 seconds of lifetime. So when it was created and when it expires, 60 seconds. The binary security token, this is the cert, the X509v3 cert that can be used to validate the signature. And receivers should only use that cert and trust that cert if they know it. And that can usually be checked via a thumbprint. All right, so here comes some more interesting parts. The signature, there are The signature method is here. You can see it says RSA SHA-256. That's what we configured. There are 3 elements that are being signed from within this document. First, the TS100 element, and that refers to this timestamp. So this is the TS100. So it's referring to this timestamp. That is included in the signed material for the signature. The second is the body 102, and as we expect, that is down here. That is the just the body of the SOAP message. The last thing that gets signed, included in the signed material, is the 103, and I bet you know where that goes. That's the WS addressing 2 element. There is the ID, so that's going to be signed as well. All of those are signed via RSA SHA-256. Each one is included in the signature with the SHA-256 digest. And this is the resulting signature value. Okay, so that's kind of a pretty printed version of the signed payload. We can't try to validate that, but we can at least use it to understand what's in the signature. Okay, so going back to the terminal, if we then try to validate that, we would expect it would fail because it's expired. We only had a 60 seconds lifetime on this signed document, so it's probably already expired. So before we try to validate that, let's look at the validate callout. So I've got a separate proxy for validate. It is very similar to the sign proxy in that it has a single conditional flow. It checks for post on the validate 1 path, looks for an XML document, assigns the key, the cert, thumbprint value, and then calls validate and sends back a validation response. Key and cert are the same. The validate callout uses this configuration. We're looking at the source, that's the message content, that's the document I'll post in. The required signed elements here are at least timestamp and 2. And I actually think this is a logic error. If you're not validating the body, you're at risk. So you want to validate also the body, but I'm just using this as a demonstration. At a minimum, the inbound document needs to have these elements signed according to this configuration. And again, these prefixes need to be active in the inbound document. We're going to accept any certificate that has that thumbprint, insist on SOAP12, insist on SHA-256 for the digest method, and RSA SHA-256 for the signing. And of course, there's the validate class. So pretty simple. And then the response is just going to be an XML document with some diagnostic information and the error if there is any. So let's start a debug session. And that's just for the validate proxy. And I'm going to send a couple requests in. So validate, sending in this previously signed document, which we now think is expired. So I'll send that in. And it's telling me there's an error, which we kind of expect because it's expired. So let me create a new signed version. This will have a new expiry, and then go back and validate that one. And we see that one succeeds. So we sent 2 requests into the validate proxy. The first one failed, and we can see that here. We just highlight the custom policy. We can see the WS error, and it says, look, the timestamp expires is past. It's in the past. We expected that. So it happened to expire, 5 minutes ago. And so that signature would be rejected. In this one, the Java validate works. So there's no error. It checks the expiry. There's 52 seconds remaining. This is what elements were found to be signed. The required elements were just the timestamp and the 2. So that was sufficient, and everything else checked out. The certificate thumbprint was a match. This is the one we required, and this is the one that was found. So the validation works. And that's it for the demonstration. If you've got any questions on this, let me know.